Galvanic Cells by Tabitha, Arshum, and Zack. A galvanic cell, also known as a voltaic cell, produces electricity from a thermodynamically favorable reaction. An everyday example would be a battery. The galvanic cell that will be used in this video is a standard state cell, 1 mole of solutions at 1 atmosphere and 25 degrees Celsius, with a solid zinc electrode in zinc 2 sulfate solution connected to a solid copper electrode in copper 2 sulfate solution, where electrons run across this wire, therefore producing electricity. In order to understand how and why this occurs, we must first address oxidation and reduction. Oxidation is a half reaction in which the element's oxidation number increases. This occurs when an atom loses an electron, usually forming an ion. In this case, solid zinc's oxidation number is increasing from 0 to positive 2, losing 2 electrons. Reduction is a half reaction in which the oxidation number decreases. This occurs when an atom gains an electron, which usually forms a neutral atom. In this case, copper 2's oxidation number is decreasing from positive 2 to 0, where it is gaining the 2 electrons the zinc is losing. Now, why are oxidation and reduction important? They are important because these two half reactions occur at the anode and cathode respectively. They help a mnemonic to memorize which reaction happens at which electrode is an anox red cat. In this example, the zinc is the anode because it is being oxidized, anox, and the copper is the cathode because it is being reduced, red cat. In a galvanic cell, electrons move from the anode to the cathode through a wire. This is supported by the above example where the electrons move from the zinc, which is being oxidized, to the copper 2 plus ions, which are being reduced. If a galvanic cell is allowed to run long enough, so many ions in the cathode solution are reduced that you can visually see their precipitation onto the cathode. In our example, the amount of solid copper will grow as the reaction takes place. At the anode, so many zinc atoms are oxidized that you can visually see the anode dissolve and zinc 2 plus ions go into solution. Therefore, the amount of solid zinc decreases as the reaction occurs. Now the question is, how is it determined that the copper was the metal to be reduced? Why couldn't it have been zinc? To determine this, we must look at reduction potentials. Reduction potentials tell us how likely reduction is to occur. Between two half reactions, the reaction with the higher reduction potential will be reduced, and the reaction with the lower reduction potential will be oxidized. In our case, copper has a reduction potential of positive 0.34 volts, and zinc has a reduction potential of negative 0.76 volts. Therefore, this supports that the copper 2 plus ions will be reduced, and solid zinc will be oxidized. To calculate cell potential, the total voltage of the cell, we add the reduction voltage to oxidation voltage. The reduction voltage is the reduction potential of the element or compound being reduced in the half reaction, in this case copper. Oxidation voltage is the opposite sign of the reduction potential of the element or compound being oxidized in the half reaction, in this case zinc. If the cell potential is positive, the reaction is thermodynamically favorable and will occur spontaneously, which is the definition of a galvanic cell. If the cell potential is negative, the reaction is not thermodynamically favorable and will not occur spontaneously. A cell with a negative cell potential is not a galvanic cell, but an electrolytic cell, which will not be discussed in this video. Here, the standard state cell potential is positive 1.1 volts, which means the cell releases 1.1 volts. Now you may have noticed an odd-looking U-shaped object on slide 1. That was a salt bridge. In order for the galvanic cell to run, it must have a salt bridge to balance out charge. As the galvanic cell runs, the anode solution will become increasingly positive. See how the anode solution became more positive because there are more zinc 2 plus ions than sulfate ions? And the cathode solution will become increasingly negative. See how there are more sulfate ions than copper 2 plus ions? The salt bridge helps counteract this process by allowing negative ions to move into the anode solution and positive ions to move into the cathode solution. In our example, 2 chloride ions enter the zinc 2 plus solution and 2 sodium ions enter the copper 2 sulfate solution. This concludes the basics of galvanic cells. Thanks for watching.